How does a 10-pound rodent living above 10,000 feet keep an entire mountain ecosystem from collapsing? And how is it that fewer than 4,000 of them still exist on Earth, in one place? You're about to find out. Meet Marmota olympus, the Olympic marmot. Not just rare, not just remarkable, one of the only large mammals on Earth found nowhere else but a single mountain range. Its family tree begins in the order Rodentia, the rodents, making it a cousin to squirrels, prairie dogs, and groundhogs. It belongs to the family Sirenidae and the genus Marmota, a group of large ground squirrels distributed across the northern hemisphere. Within that genus, the Olympic marmot is one of 15 recognized species worldwide. Its closest North American relatives include the hoary marmot of Canada's Rocky Mountains and the yellow-bellied marmot of the Sierra Nevada. But what makes the Olympic marmot extraordinary isn't just its family, it's its isolation. Separated from its relatives by thousands of years and surrounded by ocean, rainforest, and glacial topography, this animal evolved alone. It became something entirely its own. The Olympic marmot is the largest native rodent in Washington state. Adults weigh between 7 and 18 pounds, and that number isn't consistent. It swings dramatically depending on the season. Before hibernation, their weight is about 18 pounds, and after hibernation, closer to 7. That's a 60% drop in body mass, survived entirely on stored fat. Its coat shifts with age and season. Juveniles are darker. Adults display a warm tawny brown to cinnamon coloring with a distinctive white patch on the muzzle and forehead. Their tails are long, bushy, and darkened at the tip, a perfect visual signal to colony members. They stand roughly 17 to 26 inches long, stocky, barrel-chested, engineered for burrowing, not speed. Those forelimbs carry disproportionate strength. Their claws are purpose-built excavation tools, capable of moving hundreds of pounds of alpine soil per year. And the whistling? That's not random. It's a sophisticated alarm system, a full communication language we'll break down later. The Olympic marmot lives exclusively inside Olympic National Park, a UNESCO World Heritage Site on Washington State's Olympic Peninsula. Not just in the park, only in the subalpine and alpine meadow zones above 4,500 feet, where summer lasts just 70 to 90 days per year. This is not a forgiving landscape. Snowpack can exceed 10 feet deep. Temperatures plunge well below freezing in winter. And yet, the Olympic marmot has staked its entire evolutionary existence here. Why? Because those meadows, for their brief summer window, are extraordinarily productive. Forbs, sedges, grasses, and wildflowers burst in dense carpets, offering calorie-dense vegetation for a creature that must consume enough energy in 90 days to sustain 7 or 8 months underground. The terrain itself shapes colony behavior. Marmots cluster near rocky outcrops. Boulders provide lookout posts for sentinels and thermal shelter. Talus fields anchor burrow networks that go multiple feet underground. This is their fortress, and they defend every inch of it. If the Olympic marmot is already blowing your mind, you haven't seen anything yet. We've got videos on the most extreme, most misunderstood, and most spectacular wildlife on the planet. Hit like and subscribe now so you never miss one. Hit that bell. Every upload matters. And while we're here, drop a comment below. Did you know the Olympic marmot existed before today? Now, back to the mountain. Why does a single whistle make an entire colony vanish in seconds? And how do they know which whistle means run and which one means look? Almost no one watching this animal in the wild realizes it has a multi-signal alarm language, and it changes everything about how this colony survives.
Olympic marmots are highly social, living in family colonies of 2 to 30 individuals, typically consisting of a dominant male, one or more females, their offspring, and occasionally unrelated yearlings. Within this structure, designated sentinels take elevated positions on boulders and scan for threats. What they produce isn't just noise. Different call types encode different threats. A single sharp whistle signals aerial danger, like a golden eagle or peregrine falcon. A series of rapid calls signals ground predators, coyotes, bobcats, cougars. The colony reads the code and responds accordingly.
Beyond alarm behavior, Olympic marmots engage in extensive social grooming, play wrestling among juveniles, and greeting rituals involving nose touching, a behavior that reinforces social bonds and potentially allows individuals to exchange olfactory information. Foraging behavior is strategic. They eat in the morning and late afternoon, retreating to burrows during the hottest midday hours, a rhythm dictated by both predator pressure and thermal regulation. The Olympic marmot doesn't hunt. It is almost entirely herbivorous, consuming over 60 species of plants, grasses, forbs, and roots. Occasionally, juveniles have been observed consuming insects, but the caloric engine of this animal runs on vegetation and volume. In the subalpine meadows of the Olympic Peninsula, the marmot sits at a critical position in the food web, not at the top and not at the bottom. It's a keystone prey species. Primary predators include the golden eagle, coyote, bobcat, and American black bear. Historical records also suggest the now locally extinct Olympic wolf once played a major role in shaping marmot colony behavior, an ecological ghost still influencing their alertness patterns today. The golden eagle is arguably the most dangerous threat. Capable of striking at speed from altitude, it targets juveniles who haven't yet learned to read sentinel calls. Colonies with experienced sentinels show measurably higher juvenile survival rates, suggesting learned behavior passes through generations. But interactions aren't only about predation. The burrows the marmot excavates create habitat used by dozens of other species, from small songbirds and insects nesting in unused tunnel sections to invertebrates thriving in the enriched soil around burrow spoil heaps. The marmot's grazing also controls vegetation structure, preventing any single plant species from monopolizing the meadow and maintaining the biodiversity that supports pollinators, nesting birds, and reptiles. Remove the marmot, and the meadow's architecture, biological, physical, structural, begins to deteriorate. A single colony's burrow network can extend 15 to 30 meters underground, with chambers for sleeping, hibernation, and waste. Over years and decades, this excavation fundamentally alters soil composition, aerating compacted subalpine earth, increasing water infiltration, redistributing nutrients, and boosting local plant productivity. Their scat deposits nitrogen directly into the soil, acting as a biological fertilizer that concentrates flowering plant growth near active colonies. Studies in Olympic National Park have demonstrated that meadow areas with active marmot colonies support measurably higher wildflower diversity than abandoned meadow sections. Marmot burrows also retain snowmelt longer in the soil profile, a function that is increasingly critical as climate change alters precipitation timing in the Pacific Northwest. This delayed release water supports plant life well into late summer droughts. In short, the Olympic marmot digs the wells that the meadow drinks from. The Olympic marmot is active above ground for only 90 to 120 days per year. The rest of the time, 7 to 8 months, it exists in a state of controlled physiological shutdown. During hibernation, its heart rate drops from 100 beats per minute to fewer than 10. Body temperature falls to within a degree of the surrounding burrow soil. Breathing becomes nearly imperceptible. The entire family group hibernates together in a single chamber, their shared body heat forming a thermal buffer that prevents the den temperature from falling fatally low. This is not comfort, it is survival mathematics.
Emergence occurs in late April or May, triggered by snowpack recession and day length. The first weeks above ground are critical. Animals are at their thinnest and must begin foraging immediately to rebuild fat reserves before the next breeding cycle. Olympic marmots reach sexual maturity at 2 to 3 years old. Pups are born underground in May or June, eyes sealed, helpless, and emerge above ground at approximately 5 to 6 weeks old. Average lifespan in the wild, 6 to 8 years. Maximum recorded, 13 to 15 years. Every single winter survived is a physiological achievement.
The IUCN Red List currently classifies the Olympic marmot as vulnerable. Population estimates range from approximately 2,000 to 4,000 individuals, confined exclusively to subalpine and alpine zones within Olympic National Park. In the early 2000s, researchers documented severe population declines. In some monitored meadows, colony numbers dropped by over 50% within a decade. The cause is climate change. Warmer, drier summers are shrinking the meadow vegetation window. Reduced snowpack means marmots emerge earlier, but if spring vegetation hasn't yet grown, they face food scarcity at their most vulnerable. Some colonies are emerging from hibernation into barren, frozen soil. The introduction of coyotes into the Olympic Peninsula, historically absent, has added a novel predator pressure the marmot's alarm systems did not evolve to handle optimally. Olympic National Park's research teams conduct annual monitoring. As of the most recent surveys, some meadow systems have shown partial recovery, but the species remains highly sensitive to continued warming trends. So, we come back to the question we opened with. How does a 10-pound animal keep a mountain ecosystem from collapsing? Now you know the answer. It digs the soil. It seeds the meadow. It feeds the eagle and nourishes the wolf. It filters the snowmelt and rings the alarm for everything alive within earshot. It is not a resident of this mountain. It is part of its machinery. If warming trends continue at their current rate and the subalpine meadows of Olympic National Park shrink upslope by another 1,000 feet, the Olympic marmot will have nowhere left to go. There is no higher mountain. There is no other range. There is no migration corridor. But here is the question we'll leave you with. What happens to an island species evolved in total isolation when the island itself starts to disappear? Comment below, and don't forget to hit like and subscribe for more amazing wildlife adventures. Thank you for watching.